Guys, so here we have four equations. Actually, four equations having four functions. This is a function where the value of this expression is dependent on that variable x. So here fx is actually a function of x, where these expressions are actually variable on x. So fx, gx, mx and nx, I have taken four equations. Now you can see this is actually a quadratic equation, but again it has a variable. I am not considering that y thing, I am just considering that x thing. And here if I just observe these things, what can I see? I can see two things. First of all, that the variable has different powers, right? So actually all these equations are actually called as polynomials. But what to say about this? First of all, when this variable having a power of 3, we will name it as cubic polynomial. So this polynomial is named as cubic polynomial. When the power is 2, we will call it quadratic polynomial. When the power is 1, we will call it linear polynomial. You heard a linear equation before, it is linear polynomial. And there is no power or no power here, only as number is here, constant number, we will call it 0 degree polynomial. So actually these are the degrees of a polynomial. So when the degree is 3, the power is 3, so we will call it the degree is 3, we will call it as cubic polynomial, or quadratic polynomial for degree 2, linear for degree 1, and 0 degree polynomial for not having it. Later we will start some new thing. Guys, you have here four different polynomials. First of all, I say this is the polynomial which I am considering as a dividend, okay? And this polynomial we are considering as divisor. So this is dividend, this is divisor. And after dividing this thing, we are getting a result here as a quotient and a remainder here. This is a very simple division formula. Now one thing to be observed, that dividend has a higher degree than the divisor, and definitely it will work if it is having this kind of thing. The dividend will have a higher degree than the divisor. You can see it's a cubic and it's a quadratic. And then we will get a remainder and a quotient. First of all, we will get a quotient and a remainder. So here comes the remainder theory, which we learn from now. Now what is said in remainder theorem, that let px be a polynomial which having a degree greater than 1. Now if and a be a real number, okay, so a actually be a real number. Now if px is divided by x minus a, we will get a quotient definitely, and we will get a remainder, and that remainder will be a pa, so a function of a. This is the remainder theorem. Let px be a polynomial which is having a degree greater than 1 and a be a real number. If I divide px by x minus a, I will get a quotient and definitely a remainder having pa. So later on we will do the remainder theorem examples and problems. So here we have a problem. This is a polynomial is given. We have to find the remainder of this polynomial when it is divided by x minus 1. I repeat, we have a polynomial and we have to find the remainder of it when it is divided by x minus 1. How to do it? As it is stated in before by the remainder theorem. So if it is px is divided by x minus a, the remainder will have a function of pa. So that a1 will be represented here. What we will do? Here we are divided by x minus 1. So here a is 1. So the remainder will having a function of pa. So p of 1. We will put here p of 1 plus 1 is as a power 2, 4, 3 minus 2 into 1 square plus 1 plus 1. So 1, 2 cancelled, 2, 2, 2. So the remainder we will have is 2. Okay.